Good morning, everybody. My name is Tom Purcell. I'm a consultant with Chariot Solutions. This morning, we're going to hear from Ada Rose Cannon. She's co-chair of the W3C Immersive Web Group and a developer advocate at Samsung Internet. Ada's talk is titled Augmented Reality on the Web. Given the events of the past year, anything that can augment our reality is fine with me. So with that, I'll hand it over to Ada. It's all yours, Ada.
Cool. Thank you so much. Thanks for a really nice introduction. Yeah, so as Tom said, I'm Ada Rose Cannon. I'm here to talk today about WebXR and augmented reality on the web. But first, before I get stuck into that, I want to talk a little bit about me and who I work for. So I'm a developer advocate for the web browser Samsung Internet. Samsung Internet is an Android web browser, which is a fork of Chromium, which is maintained by Samsung. We have features aimed at power users and people who are more privacy aware, with features like ad blocking and tracking prevention, and a fully customizable interface. I think it's a really great web browser. You can download it from the Play Store on Android, and I really recommend trying it out, especially if you're a web developer. We have about 500 million users, and we're actually a pretty big browser for a browser that very few people have heard of. So if you can test your websites in our web browser, I'd be really grateful. And naturally, it supports all of the augmented reality features I will be talking about today. At least all the ones that have been released anyway. As a developer advocate, I try to help developers with the latest features in the web platform to build websites which make the most of everything the web browser can offer. If you have any questions about augmented reality on the web or Samsung Internet in general, please reach out to me or any of my Samsung Internet colleagues through email or social media. I understand at the talk there will be a live Q&A, and I'll be happy to answer any questions that may arise, and you can drop them in the Slack channel in order to ask them. Right, back to the topic at hand. Augmented reality on the web with the WebXR device API, which is also known as just WebXR for short. In this talk, I will probably also mention virtual reality quite frequently. This is because virtual reality and augmented reality have really strong links. And in WebXR in particular, the lines between augmented reality and virtual reality get very blurred, as they have a lot of overlapping functionalities and APIs. So what is WebXR? Well, WebXR is an API that's built into web browsers that allows you to access the sensors and displays of XR hardware and render virtual content using web APIs. I mentioned XR a lot so far, and by XR, it's just like the umbrella term for augmented reality and virtual reality and mixed reality. The X is just for whatever kind of reality the technology is called. It's like a general umbrella term for immersive technologies. And the web APIs you can use with WebXR, here I mean JavaScript and WebGL and WebGPU. I don't so much mean HTML and CSS. Right now, HTML and CSS have a really hard time rendering in headsets. And this is something which we're looking to get better in the future, but right now that's the situation. So it's almost entirely a graphics-based API. Web browsers are available on a wide variety of platforms. So WebXR itself is designed to be abstract enough to smooth over the differences between these hardware platforms, and also the differences between AR and VR to an extent. This lets you build a single experience that works on handheld devices, headsets, and AR and VR. This is all a bit abstract so far, so I'm just going to quickly show you an example of WebXR in action. Hopefully it loads. There we go. So here is a video of augmented reality in Samsung Internet. It's launched from a normal web page and it renders the scene using WebGL. I push a button on the page to start the WebXR session, and the browser pops up an information dialog explaining the security implications of augmented reality. As a developer, I can get information about the user's environment and use that to correctly render the cactus model over the camera feed. This experience works really well on a phone, but it should work just as well in an AR headset as it does on a phone. But these capabilities are nothing new. Native apps have been doing this kind of thing for a long time now. So why does WebXR exist? Well, as its name suggests, WebXR combines the web and XR technologies. And that's where the magic happens. There are benefits that XR can gain from being on the web. And equally, there are benefits the web can get from having access to XR devices. Most importantly, the web is the biggest software platform in the world, with billions of users, many of whom are already using XR-capable devices, whether they know it or not, in the form of the phones in their pockets. A single XR-capable website will work on many kinds of XR devices using a single build. So today, that pretty much means augmented reality on phones, as this is the most popular device, virtual reality headsets, the next most popular device, and augmented reality headsets, which are currently not that common, but might be becoming more widely available in the future. The WebXR device API has been really cleverly designed to abstract away the differences as much as possible, to enable you to build something that will work on any device, even ones you are currently unable to test on. But this includes devices which haven't even been developed yet. This is the power of the web. Like, websites don't break every time your browser updates, or you get a new device, or you change your operating system. Websites built 25 years ago still work today on hardware such as mobile phones, which were just science fiction when that particular website was made. And the same is true for XR sites. The XR landscape is evolving fast, and we don't know what XR devices will look like in 5 years, let alone 25 years. But by using WebXR, in theory, a website you build today will still work long into the future, no matter what bizarre immersive hardware that future may bring. One really powerful ability for writing software on the web is that you don't need to download anything in particular before you run it. WebXR capable sites are loaded through an ordinary web browser. They can start quickly and can progressively load content as it downloads, giving almost instantaneous engagement. And the nice thing is that because you don't need to wait for approval by app stores, you don't need to give app stores a cut of your revenue either. If you build something, you can just push it up to a server and your users can start experiencing it immediately. And one last thing I wanted to mention is that the web developer community is huge and extremely active. There are new libraries and resources that are developed continuously. The skills needed to build an excellent XR-capable site rely on a mix of web and graphics skills. And the web has had a lot of experience with graphics now. WebGL has been available for over 10 years, and there are large communities based around popular JavaScript libraries for dealing with it, such as Babylon.js, 3JS, A-Frame, and even more. By letting developers quickly skill up with graphic skills needed for XR, they can quickly start building XR-capable websites. These brilliant communities will also let graphics developers get the web skills they needed to make their XR experiences fast and optimized for the web. So conversely, what can XR do for the web? So XR devices, whilst very niche today, over the coming decade may very well integrate thoroughly into our lives, just like smartphones have today. WebXR can support a wide range of devices, So today, typically, that will mean through a handset like a mobile phone, as it's the most widely available AR-capable device. And mixed reality mixed reality headsets, whilst currently expensive and pretty hard to get hold of, are becoming increasingly more accessible. There will come a time when these devices, AR headsets in particular, very rapidly become the new standard for personal computing devices. Much like mobile phones did 15 years ago, how they suddenly became incredibly powerful over a few years, AR devices may become the way the majority of content is accessed. This may seem really unbelievable today, but if you had told me back in 2007 that the majority of web browsing would be happening on mobile phones, I don't think I would have believed you looking at the existing landscape. And if the web is not prepared to work on these new XR devices, then when that time comes, when the majority of content is browsed on XR devices, the web would cease to be a relevant content platform. So WebXR is really important for ensuring the existence of the web through the next series of hardware platforms. XR technologies allow websites to do things they could never do before. So these capabilities are considered pretty standard in the XR ecosystem, but they are pretty new, they are entirely new to the web. These capabilities will allow us to bring new XR-powered experiences to the web to help keep it evolving, such as displaying content on head-mounted displays and displaying it stereoscopically so the user gets a sense of presence and scale. Being able to sense the user's environment and place content on top of it, and to track the position of the user's head and hands to enable them to interact with this content in a physical manner. And do all of this using the existing web graphics stacks. By bringing web content outside of 2D monitors, we can bring many experiences that do not work well when constrained to a single 2D rectangle you've come to expect of a display or a web browser window. We can enable users to interact comfortably with 3D content. We can put this content into the context of the user's environment, letting them explore spatial data and experiences in a more naturalistic fashion compared to using them on a 2D screen. So I'm just going to get a drink. So hopefully I've now clearly communicated the value of WebXR. But probably what is more interesting to many people is what are the values of WebXR and how it came about? Because this determines the direction WebXR is going to take in the future, as it's still early days. So let's dive a little bit into how the WebXR standard is made. So the group I'm chair of is called the Immersive Web Community Group and the Immersive Web Working Group. And these are the groups that develop the WebXR device API. These are groups in the W3C, the World Wide Web Consortium. And the W3C is where the majority of the standards for the web get developed. These APIs are designed openly in the public. If you go to our GitHub, you can read up on the specs, see what is currently being developed. You can read the agendas and minutes of all the past meetings, even the most recent ones. And if you want to take part, you can join one of these groups. So the group that's open to everyone is the community group. This is the group where the majority of the work happens. It's where specs are created and it's where the specs are first thought about and the majority of the work is done to make it developed. And then once it's developed to a pretty mature state and people have started to implement it in web browsers, it moves across to the working group in order to get finalized as a spec ready for the web. It's quite unusual for a spec to be developed this way, with the majority of the work done in the community group where everyone can take part. But it's a decision we made to really improve the access of this, as this is such an important technology. But if you are a member of a company that's a member of the W3C and you are interested, please ask your AC rep to join. Or if you want to join the community group, please join. We're always happy to have new members and have more people taking part. Because WebXR is a web API developed within the W3C, it has a high standard to meet in order to be permitted to exist in web browsers. As a group, we try to develop APIs which expose as many of the latest XR features we can manage. Unfortunately, many of these are based around giving a deep understanding of the user's environment. So we have to balance this against accessibility, privacy, and security to the extent that one would expect from the web. This forces us to draw a fine line between how much environmental understanding we can provide versus risking the privacy of users. And finding the right balance here is very hard and has to be done very carefully. Users of the web have a high expectation that a web page isn't spying on them, and WebXR cannot be an API that breaks that expectation. In addition, the web does not deprecate APIs unless something really disastrous happens. So whatever API we design must also be future-proofed for any kind of new XR hardware. The WebXR device API often exposes sensor data, but if we expose the raw sensor data, this can lead to privacy issues, such as if you can work out the specific very subtle manufacturing defects in a device, you can uniquely identify a piece of hardware throughout the entire internet. This is known as fingerprinting, where they abuse the API to do this. Or if we have an API that's too finely grained, we may expose more information than a developer actually needs to perform a general AR task. Letting a user use this additional information to find out information about the user they wouldn't want exposed. It's amazing how clever some of the hackers can be for manipulating these APIs. For example, the current API for detecting the real-world environment is known as the hit test API. And the way we've built it to be secure is that it only lets you query from single rays, rather than giving you the raw shapes or meshes which the underlying platform actually has access to. In addition, the data we give you back is slightly fuzzed, just to prevent the very subtle information that a hacker could use to fingerprint your device. This way, it ends up being nice and secure for users. But developers are always requesting access to more information. So we are working on more powerful real-world geometry APIs, but that's further down the line. And we will have to warn users of when stuff might be dangerous for them. So these are the kind of issues we need to worry about when making new APIs for the web. All right, so that's the constraints we're working with. But the other important aspect of who is driving the API forward within these constraints. Well, the working group includes participants from Amazon, Google, Apple, Facebook, Magic Leap, Microsoft, Intel, Samsung, and many more. Some of these companies have browsers. Some of them have XR-capable hardware, or some have both. Some of these companies have XR-enabled software that needs to be able to run on the web, and we have to meet their requirements. All of these organizations and individuals have opinions on what WebXR needs to do to work for them. The goals of these organizations, combined with the requirements for new web APIs, is what shapes the API. So now I've talked about that, what actually is currently being developed. So these are just like a few of the things that I'm most excited about personally. There's a lot of more stuff being developed. A lot of work is done in parallel. And so if you want to find out more, please check out GitHub, have a dig around, look through the issues and the pull requests and see what's currently happening. So firstly, my favorite thing, hyperlinks or navigation. So you may be surprised to hear that navigating between websites, which the web has been able to do since day one, continues to be one of the hardest things to do in WebXR. Because when you have the ability to control every single pixel on the screen the user can see, there is no space to securely inform the user that of the current website they're visiting. There's no way to have that level of trust. So securely navigating between websites securely actually becomes impossible. An evil website could quite easily pretend to be another site like yourbank.com, or it could even spoof being your entire web browser and start hoovering up everything you're doing in this spoofed environment. So something that should be coming soon will let you navigate between pages on the same domain. We consider that safer because developers generally have control over everything that's happening on the same domain. Whereas traveling between domains is still an ongoing challenge and not something which we'll be able to let you do yet. The next is the Layers API. So Layers lets you display static media like images and videos or simple geometric shapes on top of or behind your 3D environment. So this may seem like quite a simple feature, but it's actually a really powerful one. So this is useful for displaying stuff like 360-degree videos and fancy skyboxes, or areas with text or interfaces. Or if you're building a virtual reality cinema, you would use this for displaying the movie you're seeing in VR. And what's special about these areas is that they are rendered by the browser, so they get some really huge advantages, such as if you're rendering video, they get significant performance improvements because you don't have to copy each individual video frame to the graphics card. The web browser handles it for you. This lets you free up a lot more time that you can use to make your scene even more visually impressive. It also does asynchronous reprojection on the layers. So what this means is that it gets rendered a lot closer to the point where the photons come out of the screen and go towards the user's eyes. So this makes them a lot crisper to read, a lot less blurry. So generally, reading text in virtual reality is just considered a terrible idea and you shouldn't do it. But at least if you're using layers, it does make it significantly more comfortable and a lot more easy to get a good user experience. We're even considering this as a method of getting HTML and CSS into WebXR. And that is something that's currently being actively worked on. But layers is something you can try out in some browsers today. And the final feature I want to introduce is a very simple but a very useful one. So this is lighting estimation. So it uses a combination of the sensors, cameras, and some machine learning algorithms to generate an environmental cube map in augmented reality. And it gives you access to this cube map as a developer. So you can use this to make virtual objects feel like a much more natural part of the environment. This is a really small, subtle change that greatly increases the fidelity of your augmented reality scene. and is a really great thing to work on, to work with. So hardware-wise and capabilities, what does the web and XR look like today? Like, what can you build right now? And I showed you a demo earlier on a real device, but this is going to be like a little bit more in depth about the capabilities of the hardware you will likely see WebXR be able to work with today. So the first thing I'd like to mention is head-mounted virtual reality. This was actually the first initial target for XR on the web. There used to be an old API called WebVR, which only did virtual reality and has since been deprecated. And it was started developed around the time the DK1 was released. And when that was deprecated, it was a challenge for WebXR to totally provide the same feature set as the WebVR API. That was like our minimum bar before we could release it. And so what can it do? Well, it can access the position of the headset and let you render to it. You can get the position of the tracked controllers and work out what their buttons are and what buttons are being pressed. And this same API can be used to access the hand information if the device has some kind of hand tracking, like in the demo video. And because the hand information actually comes through as an extension of the controllers, it lets you, as a developer, detect whether this hand information is available. And if it is, you can render hand models. And if you don't want to support that, you can just render normal controller models. So this is the kind of thinking we do that makes the API future-proof by making it extendable so that when new hardware things, in this case, when hand tracking came along, it lets us build on top of what we were working on before. So old sites that didn't support hand tracking still work even on a headset that does support hand tracking. The next one I want to talk about is handheld augmented reality. And that's because it's the most widely available form of XR you'll come across today. And handheld AR is interesting because the display you render from is also the same input for the controller. So they will have very similar locations. But when you tap the screen, we won't just make you work out that you're using a screen and that you should use the viewer position to track from. We give you special transient inputs so that when the user taps the screen, you can get the three-dimensional position in real space of that tap immediately, and you can start using it to interact with the scene. This also means that you don't need to focus specifically that the user is using a mobile phone. You don't need to know the screen size, like its width or its height, or even where they tapped. The WebXR Device API handles it all for you. So this is really handy. But in exchange, the handheld devices probably won't have any kind of external XR inputs. So the user won't be able to use their hands or any controllers to reach out and grab stuff. They're only going to be tapping stuff that's on the screen. At least that's the way it currently works today in almost all the hardware. But the nice way of, because it's nice and abstract like this lets you build a single experience that works on phones and headsets without needing to write too much extra code to specifically handle handheld augmented reality. The next thing we have is head-mounted augmented reality. So these are headsets like the Magic Leap or the HoloLens. So this kind of sits in between the two. Like, it has the same form factor and controllers and capabilities of virtual reality, but also has the real-world tracking capabilities of augmented reality. This shared API surface is what enables different kinds of devices to be supported. You don't have to specifically think about targeting specific devices. And if you build your WebXR experience with this mindset, you will end up building something that's going to continue to work into the future on no matter what kind of devices come out. So these are some of the projects, like some ideal use cases for WebXR, and highlight the thinking you should put into when you build them. So use case 1, a drawing application. So this is something that lets you be creative. And because you want to be creative and getting physical, you need some kind of hand tracking. So this means it's going to be head-mounted virtual reality or head-mounted augmented reality. You don't need any kind of access to the user's environment, so VR is still totally fine. But you want to reach the widest possible audience. So what you can do is that you can provide progressive enhancement to also support augmented reality on phones. And even though users won't be able to create any content because it doesn't make sense for that form factor, you can still let them view in augmented reality the content people have produced before. So this lets you maximize the engagement through handheld whilst getting the power of the other two if the hardware is available. Next, a furniture preview application. So for example, if you went to a furniture website, you would want to push a button and view the furniture in your environment. And because it needs to be in your environment, it needs to use augmented reality. But you won't need to have to reach out with your hands to grab anything. So handheld augmented reality is totally fine. But if you're already supporting head-mounted augmented reality, it's not actually too much work to support virtual reality as well. And if you provide a fallback environment, a user who really wanted to see the scale of something with stereoscopic view could view it in some kind of fallback VR environment so that they can see the scale stereoscopically. And the final example I want to talk about is a virtual reality promotional website. So you want to reach the widest possible audience, and that's the most important thing to do. So you need to at least support handheld augmented reality. So don't make it so that controllers are a necessity. But virtual reality is also a widely available platform. So if you make it pretty good there, it'll be an even better enhancement. And you can just let them do the augmented reality experience, but in some branded environment. And since you're already supporting AR and head-mounted VR, you might as well do head-mounted AR as well. That way, whatever you build will last long into the future on future XR devices. Right, let's talk about getting stuck in and building something. And I'm going to mention a few things that are worth thinking about when you're building your WebXR sites. So firstly, how do you get started? So if you're a web developer, my recommended way of getting started is A-Frame. A-Frame is a really great custom extension library. So it's a set of custom HTML element library. Sorry, it's a set of custom HTML elements that wrap 3D objects from the 3.js engine. So this lets you write HTML, like pretty simple HTML, and you get VR and AR ready WebXR capable scenes. And it's really powerful. I'm going to introduce A-Frame in this talk because it's like pretty simple to show the code for it. But if you want to jump into the deep end and you're really comfortable with JavaScript and maybe had a bit of graphics experience, 3JS or Babylon.js are great places to start, and both have excellent communities. Anyways, I'll show you A-Frame quickly. So this ordinary looking HTML web page is all the code for an XR capable scene. At the top, it includes the A-frame library as a script. And then it has some probably unfamiliar HTML elements in the body. So we have a-scene. This is a new HTML element that sets up all of the rendering environment for XR. And the other elements just describe the objects that are in it. So we have an a-box, which is rotated for 45 degrees and has the color 4cc3d9, which, as we all know, is approximately cyan. No, I'm just cheating. I just memorized these. We have a sphere with a radius of 1.25 meters. We have a cylinder. We have a plane, which has been rotated flat to become the floor. And we have a gray skybox. And when you view the page in the browser, this is what you see. Like, it's all ready to go. This is really powerful, and it's a fantastic way to quickly get started building something. Like, I've been doing graphics development almost my entire career, and I still use A-frame for almost all my projects because it gives me both the speed and rapid development of a declarative interface. But because it's built on top of Three.js, I can really dig into the nitty-gritty and have access to the low-level APIs underneath. It also has a really large and active community with loads of third-party components, letting you build stuff that's really quite advanced. So I really recommend trying it out if WebXR is something that interests you. So it's called A-frame. The website is aframe.io. I strongly recommend it. When working with WebXR, something you've got to be careful with is scale. So graphic stacks generally don't have a fixed size on flat displays. Like the sizes of stuff is given in usually in unitless numbers, and graphics artists will often work in whatever they're comfortable with. So for some people, 1 unit is 1 millimeter. For some people, it's 1 meter. But it could be an inch or a furlong. It doesn't really matter. As long as you use consistent units, everything works out because the display is flat. And this is fine if you're working on a flat display. But for XR, you're no longer working on flat displays. Suddenly, there's a real-world scale you've got to be involved with. So you have the user's physical size and the size of their environment. So suddenly we need to agree on what the size of this unit is and what axes we should use. So WebXR has defined for the web that the scale, that 1 unit is 1 meter and Y is up. And so Y is up, Z is into the screen, X is across. Obviously, if you turn your head, Y is still up, but then Z and X swap around. But what this sometimes means is that you will import a model where the artist has created it using millimeters. And so if they have a model that's 1,000 millimeters across, in your WebXR scene, it's going to be 1,000 meters across. So it's going to be 1 kilometer big. So often you'll have to shrink or rotate stuff to make it look good in your XR scene. Sometimes it just works out the box as more and more developers start to work in meters. Another problem with scale is that when you're building your 3D scene on a flat display, it's difficult to get a sense of the scale you're working at. I find that what I'm building often ends up being very large. That sphere in A-frame was 2.5 meters tall, which in VR looks great because you're in a big infinite void. But in augmented reality, people have to fit that content into their real homes and offices, which gives you real physical restrictions to the size of your content. So often, for a large immersive scene, it doesn't make sense for AR. So whilst for a virtual reality headset, you might have something that's immersive like this, on an augmented reality headset, you'll want to shrink down the content to maybe a fifth of its original size, to let people fit it into their environment, to explore it in a way that makes a lot more sense for them. If you want to be really clever, you can actually get the size of the user's environment in WebXR, and you can fit the content into the available space. But that can be a tricky thing to do and involves some lots of maths. So an easier thing to do is just let the user scale the content as much as they need. Next, performance. Like, how graphically intensive can you make it? On a scale of these Lara Crofts, I'd say like maybe one of the early PS2 ones. Like WebGL has been around for a long time, and it is an abstraction, and there are performance implications from this. There aren't really specific hard limits on what you're working on. You just have to test it and see how it goes. It strongly depends on how you implement your scene, what you have lots of, what bits are more complicated. And there are many things that can slow you down. So the important thing is to test as much as you can. This URL at the top of this slide is full of really in-depth tips and tricks to improving your XR performance or WebGL performance, and is really useful. Tools like A-Frame stats component are a great way to find out what's slowing your scene down, letting you trim away the things which are slowing it down. And as you get more used to doing graphics development, you'll find more and more tricks to make really impressive things out of really cheap effects. The important thing to be aware of is that the most popular devices use a mobile chipset. So the most important thing to do is make sure you test on a mobile phone and are getting a consistent 60 frames per second. And so just test, and that's really important. Users on the web are very impatient. So if your site doesn't load in a few seconds, they're going to leave. So try to avoid having long loading bars. But at the same time, you can't do too much stuff in the background, because if you cause too much lag and you end up skipping too many frames, you're going to make your users feel ill. So it's really important to start fast and stay fast. Performance is really important here. And the last couple of slides, I want to be like brutally honest, like what is WebXR good for and what is it not good for? So it's really good for simple single environment experiences where you can get instant engagement and you can reach a wide audience. Take advantage of that. You don't need an app store or a big download. It's easy to share on social media. So if you want to reach out to as many people as possible, WebXR is perfect. After all, the link is just a URL. And if you want to reach a wide possible audience where they don't have to use specialized equipment, this is perfect. So if reaching millions of people is more important to you than long-term single user sessions, then WebXR is ideal. Where is it bad though? So if you want to make like a full huge game, like if you wanted to make Half-Life Alyx in WebXR, that's not really a sensible option. Having huge environments the users can travel around in without reloading the page, it's going to get very big, very heavy. It's going to be very, very difficult to implement in a stable fashion. High graphical fidelity is really tricky these days after all using WebGL. There's a new API called WebGPU coming around the corner, and that's going to greatly improve performance of graphics in the web by giving you much lower level access. But it's not available right now. So you are stuck using WebGL. WebGL 2 gives you some advantages but mostly gives you more access to clever tricks you can do. But yeah, it's getting better though. And finally, large textures and big download sizes. Like if you need to get the user sat in front of a loading bar on your website, they might as well be sat on a loading bar from an app store. It's going to be, users do get very bored with loading stuff in the web. They're probably just going to close the tab if it takes too long to load. So if you only need to reach a small group of people using specific VR hardware, or you have like an 800 megabyte app, yeah, you probably best go with native, unfortunately. So sorry to end on a bit of a down note. I probably should switch those two slides around to end with the good bit, which I'll do next time. But thank you so much for listening. I've been Ada Rose Cannon, or I still am Ada Rose Cannon. You can find me on Twitter, and you can find our team at Samsung Internet, or you can reach out to us at webadvocacy@samsung.com. So thank you for listening. Do I have any questions?
Hi, Ada. It looks like we have a couple. Aaron Todd asked a couple. First of all, are there still hardware limitations that make mobile WebXR challenging? I'm reminded of the now defunct Project Tango, which required a number of additional sensors for detecting the phone's position in the real world.
So as of the past few years, many smartphones either have been putting the sensors needed to do this kind of thing into their suite of cameras on the back. So if you see a smartphone with like 3 or 5 cameras on the back, like the S21 Ultra, that actually has advanced sensors built in for really accurate AR. But even if it doesn't have the specific hardware, most phone-based AR these days just uses a regular camera and computer vision in order to do the environment detection. So yeah, it's available on pretty much all modern mobile phones these days, not just the really super expensive or specialized ones.
Okay. Another question from Aaron. You mentioned the possibility of getting the size of the user's environment in mobile AR applications.
Yes.
Is there tech right now for getting accurate measurements of objects in the user's environment, say pointing your phone at a coffee table and getting rough measurements of its surface dimensions?
So you could do something. So right now you have a single point in space, which you can fire out from any point on the screen. So you could get the user to tap on the screen on the corners of the table and then generate a 3D shape and then do stuff with that. But we actually are working on APIs to do this yourself. They'll come with a higher warning level to the user because they're like slightly more dangerous because you can effectively 3D scan the user's environment. So I would just wait for if you really want that kind of information, just wait for those APIs to come out. The ones for getting the size of the user's environment, that's more for virtual reality because it gives you the shape of the user's bounding box. So if you've done VR before, when users do virtual reality, they draw like a cage around them, saying this is the safe area I can work with. We can give you that kind of information. And I think this is the kind of information that some AR headsets could give you, but you'd have to specifically request it. And I don't think handheld AR will give you that particular information, like the room size.
Okay, Timothy Sass asked the question, can you do everything with WebXR that you can do with Google AR?
No, unfortunately. So WebXR on Android does use AR Core as a backend, but it does. We haven't exposed everything that AR Core can do. Like in an ideal world, we would expose everything as soon as it was available, but it takes a long time. As features land, it takes a long time to get them through to the web because we have all the additional privacy and accessibility requirements. And so stuff like lighting estimation is coming, or actually is available behind a flag, I believe. But generally, no. Like, I don't think you will ever be able to get a one-to-one match because there will always be new features being added to various platforms, which will take some time to filter through to the web.
I have a question, Ada. You spoke about one possible use case that I know my wife would find interesting, and that's where you are in a furniture store and you want to see what a piece of furniture is going to look like in your environment.
Yes.
How do you go about, like, okay, for instance, the coffee table? How do I go about sizing that coffee table so it's not like 1 inch tall in my living room?
So what you would do is that you would use you would probably take your coffee table to a like a 3D scanning company, or you would get your own, or you get a special 3D scanning app, and you would scan your table, and it would give you a 3D model that is already correctly scaled, so that when you put it into, WebXR, it would just work.
I see. Okay. So in other words, if I picked one from a furniture store, they would have that 3D model that would automatically scale to my environment.
Yeah, because the WebXR device API tells the thing, you are currently 1.6 meters off the floor, looking in this direction, and the floor is this far away from you. So it will place the table where it detects the floor, and because it knows your height and its location, it would then render it correctly.
Oh, that sounds interesting. Okay. Okay, I think that's about it. Ada, thank you so much for your time. If you want to hang out for a little longer, if anybody wants to add additional questions in room A, maybe for another minute or two.
Yeah,
But,
I'll be hanging out in Slack. I think I did have some other questions which I did prepare answers to.
Okay.
So I'm just gonna be like highlight some interesting things, and if anyone asks anything, just let me know. There's a good way to get if you have done graphic stuff before, like you've worked in Unity. There is a WebXR Unity exporter. It's actually pretty good. Someone's actually ported Tilt Brush to the web and called it Silk Brush, and it's a full port of the Unity Tilt Brush build for the web. So the builds are a little big and there is a loading bar, but it does work. So if you are a Unity developer, give it a go. Like, see if you can ship something to the web. I'm always happy to see stuff. And please, if anyone does build anything, please show me. I'm always happy to see it. I love seeing the stuff people build with this. Another question I get asked a lot is, can you access the raw camera feed in AR? Because like you can see the camera feed through the video, and the answer generally is no. One reason, the device is using it to do the AR, so it's actually not accessible to the browser whilst AR is using it. But also, even if it was, it's hard to do for privacy reasons, because we don't want, when you have raw camera access, you can start doing really smart stuff with machine learning to just 3D scan the user's environment and take all the information in their environment. And that's dangerous, and we don't like that so much. We are thinking of a way to do it with probably with a big warning box on it for users. But yeah, that is another popular thing I'm asked about. And it's another popular feature. And if you want to know like more information about WebXR, or like see some of the more in-depth technical support stuff, I maintain a website called immersiveweb.dev, all one word. And there's all kinds of information on there, like getting started guides, support tables, that kind of thing.
Okay, Ada, we have one more question here.
Great.
Again, Aaron asked, that A-frame example that you showed, does moving around in that environment with a VR headset come along without any additional code?
Yeah, it works out the box. You can walk around, see the big shapes. It works. Like, there's no built-in teleporting. You'd have to make that yourself. I think there's probably a component for it. But if you have a big enough room, you can put on the VR headset and walk up to the shapes, and they look great.
Great. Okay, we have to close out this session now. Make room for the next talk to come into the room. Ada, I want to thank you a lot. It was a great talk.
Great. Thank you so much. And thank you so much for everyone for listening, and feel free to reach out to us on Twitter or anything like that. Thank you.
Thank you.
Bye.
Thank you, Ada.